Every day, billions of photos are shared online. A raw uncompressed image takes up massive storage, but JPEG shrinks it by 90% instantly. How? It starts by dividing the image into millions of tiny, independent blocks, measuring exactly 8 by 8 pixels. Before touching the math, JPEG exploits a flaw in human biology. Our eyes have far more detail-sensitive rod cells than color-sensitive cone cells. Through chroma subsampling, JPEG separates brightness, called luminance, from color. It then drops half of the color detail, saving space before any actual image compression begins. Inside each 8 by 8 block, JPEG applies the Discrete Cosine Transform, or DCT. This mathematical step converts spatial pixel brightness values into a combination of 64 standard cosine wave frequencies. Low frequencies representing smooth gradients gather at the top left, while high frequencies representing sharp details sit at the bottom right. Next comes quantization, where the actual compression occurs. JPEG divides each frequency coefficient by a corresponding value in a quantization matrix and rounds to the nearest integer. Because human eyes ignore high-frequency noise, these high-frequency coefficients are divided by large numbers, rounding them straight to zero. Now, we have a matrix sparse with zeros. To store this efficiently, JPEG performs a zigzag scan, tracing a path from the top left to the bottom right. This groups all remaining non-zero values first, packing the long trails of useless zeros at the end into a tiny, easily compressed stream. By combining human perception limits with elegant wave mathematics, JPEG discards details we can't see to reduce file size by 90%. This simple, elegant lossy compression is the invisible engine that makes the visual internet possible.